Gentleman's time has expired, and the chair will now recognize the gentleman from West Virginia for 5 minutes.
Thank you, Mr. Chairman. Dr. Gangaro, when I read your testimony, if I could be paraphrasing a little bit, you're saying that one of the things, the obstacles we have, barriers that have been put up about our composite construction is being able to evaluate the durability and the cost savings over time. How would you suggest we do that? Which agency should be funded to do that, or how would we go to rectify that problem?
We have been doing some work already in the area of durability, and there is a lot that needs to be done. And some of the agencies that have been funding are the National Science Foundation, the Army Corps of Engineers, the Department of Transportation. So these are some of the agencies.
Are you suggesting that we put some language in to make sure as projects go ahead that they check for that long term?
That is correct.
Okay, thank you. Let me do. Now, Dr. Tour, this subject of graphene is fascinating to me. I've been studying it now for about 3.5 years. But I have found here in Washington that almost nobody knows anything about it, is aware of the product. So I'm curious, how would you suggest we make people aware to understand the importance of the development of graphene, and what are some of the commercial applications that we could possibly use in discussions for funding? And thirdly, what would be the best agency that we could plus up their account possibly so that we have money to be able to do more work in graphene?
So as far as getting the word out, I mean there's been a huge amount of press on graphene. I think the people in Washington have been consumed with other things of late. So that's a distraction area that I'm not sure I can speak to. But as far as the areas, this extends, and even from my own work, it goes from the medical area. We have 2 drugs, one on traumatic brain injury and stroke. Traumatic brain injury being the #1 disabler of young adults, stroke being the #1 disabler of older adults, that are based on graphene nanoparticles that have transitioned to industries. We have aircraft coatings based on graphene. We've used graphene in the oil and gas industry, and we've used graphene, as I said, for healing of spinal cord. So it's very broad. I don't think it would be wise to give it to just, say, the DoD agencies. I think that taking the money and spreading it across, as you did quite wisely, as the Congress did with the National Nanotechnology Initiative. They pushed nanotechnology across all the different agencies and said, each one of you is responsible for pushing nanotechnology through your different agencies. And so we got the NSF, we got the NIH, and the Air Force, and the Navy, and the Army, all pushing. And so it came out of all of these different sectors because it can influence all of those.
Where do you see applications that we could more demonstratively convince people that this is a product that we should be advancing?
Right. So we have,
other than I heard you say about some of that, but give me some other things that perhaps we can load our gun up a little bit to be able to promote.
Right. So on a day like today, for de-icing leading edges of aircraft, or de-icing entire aircrafts by putting a coating of graphene, you use a joule-heated resistive coating, and what it does is it makes it so that you can easily de-ice aircraft without having to use chemicals. This is just a thermal process. Or de-icing power lines. No more ice on power lines. There's no more energy. You can just coat these properly, and the magnetic field from the power line heats this just even a few degrees higher than ambient, and you'll get no more ice on the power lines. So it's very good for de-icing applications, which is something you could talk about with somebody today. And then it can extend into the medical applications. When we're talking about the #1 disabler of both older and younger adults, that what these particles can do is really quite amazing. So again, there's lots of applications. I can give you tens of pages of press releases on different application areas, even from our own university.
Okay, I'd like to see that. I know that it has the potential I guess, of being a replacement for silicone wafers in our computer.
Yeah.
But there's a band gap problem.
Right,
with
there's a
that.
band gap problem, so probably what we won't do is replace where silicon is good, we'll use it in other things. So for example, for heat release or for touchscreen displays, the problem with graphene is, as you said, the band gap is too small, it's too metallic in nature. But its mobility is so high, its mobility is 100 to 300 times faster than silicon. That means the rate at which you could do computation. So we have to think about using it in different ways, and there's actually a team actually at MIT that is thinking about using graphene not as silicon is used, but differently in computing. So if you would change the computing hardware, then you could revert to graphene. What people had tried to do is force graphene into the silicon box, and that has not worked.
Okay, thank you. Yield back.
Thank you very much. The gentleman yields back. The chair now recognizes the gentleman from Pennsylvania for 5 minutes.